So it's been a bit since my last video. I wanted to explain what I've been doing lately for this project. I'm still working on the vision stuff. So I wanted to talk about what I'm doing. So this is a single picture, and the environment that this robot is navigating in is a like apartment, cluttered apartment. There's like random crap everywhere. And if you try to use like just a basic ultrasonic sensor, it's not that great because you can't. You usually need like a uniform, flat surface. A lot of times you'll miss something that's there. So I wanted to do something that was vision related, and while I have quote unquote LiDAR, it's a single point. It's not like one of those where it shoots out a bunch of beams and you get a point cloud or something. So I'm still working with something pretty crude, but anyway, so this is one picture, and imagine you are the robot. This is what you see. Like, it's hard to gauge, like how big things are, how big you are, which in the code you'll have a volume set, and then you'll operate around that volume when you do math to not run into things. So the thing takes 15 images. It takes 15 because I wanted a really wide field of view, and the more images you have, the more like points the stitching algorithm can use to join images. And it does some like crazy transformations like a sphere, so the images get distorted when you get a final result. So for example, this is the result from these images. Like, it's really good. It puts them together. There's some warping, like there's a curve here, but the more non-uniform your environment is, like, more images helps. And you can tell how like nasty your photos are using some techniques. Like what I mean by that is, like, if uniform is, or not uniform, if an image is largely uniform, like if you just had this big black rug area and then there's like the tan carpet and then the walls, like, that's easier to stitch than an image with a bunch of random crap in it. Like entropy of the image. There's like k-means, clustering, color space segmentation. I'm not doing that at this time, but you would do something like that because it's possible for the stitching to fail, and you can have some like checks. Like, is the image very cluttered, like there's a lot of random items, and you would use more images, or if not, you would use less images. It would take less time. Of course, your field of view would be smaller. You could just do 3x3. Anyway, so I'm generating there's one thing I want to point out. I'm applying this with OpenCV, this crosshair, as a way to find the camera's center. So this is the center image. This is like the robot's looking directly ahead, and it mostly looks down, as you can tell, like to look at the ground. So you put the crosshair there, and the reason it's a crosshair is because of the distortion. It's not guaranteed to that's supposed to be straight up and down, but yeah, that's the idea. So you can tell like where the center is. And then there's two of them because you want one with the crosshair and one without, which unfortunately you can tell that it shifts it. Like the presence of the crosshair affects the panorama algo, which is not great, but it's not that bad. This project has a lot of sources of error, so it's, you know. But yeah, so then what you got to do is figure out where the center is, and that's what I've been working on lately. Let's see, where's that picture? I can just look it up. Yeah, so this is what I'm doing here. That's this image here, cropped, using finding the slope, intercepts, and then that'll tell me where this pixel is. I've been working on writing that code here, just using the basic y equals mx plus b, find the slopes, equate them to each other to find the x value that where they join, and yeah, so, and I can, you know, quickly prove it with GIMP. Like if I wanted to crop the dimensions down here, so the center should be 1138 168, and this is a little off, I've found so far. When I like manually compute it, I'm still trying to prove this. There's something not right here. These numbers don't match. The slope and the b numbers are correct, but the math to find x is not right. But the value I got was 1126, which is not correct. It's off by like 1%, but it's close enough for me. So once you have this center point, then you can start doing the vision process where you're actually, I can demo that too. The approach I'm doing is finding blobs. So, and then the other thing I want to point out is this beam, the purple VL53LOX or something sensor. It's a 25-degree beam, so it's huge. Like the farther you are, the larger it is. Like the cross section of something you need to hit to return a positive response. So if you imagine that, like pointing at the ground, the robot that's on wheels. Do I have a picture of it? I don't think so. No, I won't do that. Anyway, I don't know, I could check in here. Yeah, well, here's a good picture. You can see the beam size. Main thing I wanted to point out is the side view. Like, if you're aiming this beam at the ground, it quickly hits the ground. But you can use that as like a preemptive obstacle check. You know, like before it even begins doing the panorama generation process. If it fires the beams and detects that there's a wall like right in front of it, it shouldn't even try. Of course, you wouldn't deploy the robot in that kind of setting. You would give it enough room to be able to like turn around. But at least this robot is wheeled, so it's easy to like rotate on the same point, unlike the Torque LiDAR, the quad-legged robot, insect robot. But yeah, so I'll just go over the process of what I'm doing. Let's see. So you have your center point, and then the other problem I'm dealing with is field of view. Like, I have some other images where there's like a tape measure, and you can tell like how far away things are. But if you move the camera like forward or back, these items will get smaller or bigger, and it's hard to tell like how big they are and like where they are angle wise. It's easier to explain that with this. Yeah, so if you have a cross-section plane of something, an object, and you move it, oh god, come on. So you move it like forward and backwards like this. You can see how like the size of it changes, which is obvious, right? But I'm saying if you look at a picture, you have no idea like how big things are. And your brain knows because of the like stereography and like personal experience. But so yeah, the point of this thing is the center point. The sensors are on a rotation point here. So that center point is right here at the center of the camera lens. Unfortunately, when I designed this, I had everything aligned like across like that, perfectly aligned. But the cable of the camera was on the wrong side, so I had to flip it. And since this isn't at the center of these pegs, it shifted the camera upwards. But that's alright, it's not a huge... I can account for that in the calculations. But, yeah, so... if this is like a target, you would have to figure out like the angle of it from a pixel perspective, which is possible there's like a flaw in that idea. But yeah, so say that's like 300 pixels away. Internally, I would know that that's like 20 degrees. So I would turn to the right 20 degrees, point the beam at it, and measure it. And how do I get this nice orange box? Half-life. That's what I will show next. Alright, so there is a folder. Okay, here. So we got pen crop output. That is this file. Turn it to HSV. Oh, this isn't right. There's a step to it. First you run the histogram 1D. Pen crop output. That'll tell you the light available in the image. Yeah, V in HSV. And this currently is using the... what happened? Oh yeah, I deleted those files. This is currently using a GUI, but you would get the output values and use like an array or whatever. But so right here it says 0 to 100. You go to step 2, which is histogram 2D. Pen crop output. Let's see. And for this one, you're finding the available colors in the image. What was that? 0 to 100? Okay. Man, my memory sucks. So this... oh yeah, let me open this image. I've been working on this project for a while. This is an old one. This nasty box thing. This one was bad because the it was moving like these stiff wires. That's the whole point of the whole floating sensor assembly, like a gimbal. It doesn't have those wires to like fight the recentering. Anyway, so there's this HSV chart here, HS. I got this from Stack Overflow, And then I think, let's see, 0 to 255, 0 to 180. Yeah, so this one is the H value, H axis, and then this is the S. So then, and I think the brighter the pixel, the higher the concentration. Oh, if you look at those numbers, 1.7 to the 5th, 1.4, yeah, it decreases. So there's a really strong presence of, what is that? Somewhere here. And 50 is like somewhere there. That could be like the carpet or wall. It's like a tannish color. Yeah, so you have that rough idea, like the 0 to 100 V, then you've got this. So then you use that to apply a mask. Pen, crop, output, mask applied. 0, oh wait, HSV, 0 to 100. And then H is, I still have it, like 38 or something. I think, yeah, 0 to 38, which that you might limit it to like 36 or something. I don't know. Let's see. And then S is, well, that looks like 75, I guess, 80. Oh, 73. Okay, we'll do 70 to 75. Then you run this apply mask. That outputs an image with the mask. What is that? That looks like here. That's not what I expected though. Crop output. It gets weird. What is that? It should just be black. Let me try something else. If I have these at 0, what does that do? More. It still includes black, which is not right. Use less. Yeah, that's not enough. 40. Yeah, this is weird. Like, I don't know what that is. There's nothing like that down here. Am I using the right picture? Panorama, pan, crop, output. Pan, crop, output, mask applied. Yeah. Alright, let me do something more obvious. How about this? Orange. Somewhere like in here. H. 0, yeah, like here. What is that? Just 10. S. Oh god, what is that? Probably like here. I don't know, what is that? 100, 200. I didn't edit the right one. 180. That's close. Yeah, that orange up there. How do you give it more? 15? No. Try lowering 70. Better. Yeah. Anyway, so you gotta like iterate through it, and you'll find, you know, the other thing is, as you fill out areas with dimensions, you won't like recheck that area if you've already, particularly because of the size of that giant beam. And the TF Mini is better at, that's the yellow, it's like a 2-degree field of view beam. That one's better like beyond 2 feet. It's not very good close up. It depends on the library you use. There was one I was using, a guy wrote, it's in Python, that it was so good, like single centimeter accuracy. But the one I'm using now, I think, is like a direct output with basic commands, so it's not great. It doesn't like calibrate or do a bunch of things. But yeah, so then what happens is you find those blobs, you measure their dimensions, and then inside this thing is an accelerometer and gyro. So the gyro is supposed to be what you use to determine like sweep angle and pitch angle, but I manually verified those with a camera. Like I pointed them, took angles, set a function for aiming. Can't remember where that code is. I do have like a class-based deal, you know, that's like organized, but right now I'm just writing raw bits of code here and there. I might be in here. Yeah, there's like a conversion that takes in a degree and turns it into PWM. Yeah, 3 weeks ago. So yeah, that's what I'm working on. It's just a stupidly long process. I gotta make this into a one-liner that runs. That thing I just showed with, you know, find the things that are orange. And it's hard because this thing here, like, I still have to understand what this means. This 2D histogram. But yeah, then I have like a roadmap that I'm trying to get through. There's a lot of steps. I have a smaller one that's like nearby. Yeah, so after I get the this intercept thing, I'll start working on the blob finding and the field of view understanding to make sure that works. I don't know if this whole project could ultimately be like it doesn't work because you know, you want like stereo vision or something, but part of the journey. I forgot to record part of the process. So you've got some kind of mask applied. Where is it? Something like this. Then you have to run find contours next, which is over here. Yeah. Panorama pan crop, is that the right one? and crop output mask point. Yeah. And then when it goes through this, you can set the area, like how big of a target you want to find. And then once you have like the rectangles around the contours, you would just draw a dot on the center, which I've done that before. Well, anyway, let me just run this one. Yeah, so it's finding contours of the blue, but the size was massive, 10,000. Try 1,000. It's not succeeding. Increase it more. Yeah, this is not that good of one, but what's supposed to happen is it'll draw like a red box around the contour. Let me try 100. That's the thing, like this has so many. Oh, there we go. It'll draw boxes like that, which ideally would have drawn one like here, and the center is like here. That's what you would aim the beams at, is the center of those things. And you would take into account like the size of the box, how much area you scanned, because that beam is giant. And I know that you can just, you don't even need the vision part, you would just scan with the beam and form like a crude depth map. That's what the Twerk LiDAR does, because it doesn't have a camera. The camera like allows you to, when you have like real-time processing, you know, like visual inertial odometry or something real time, which I'm not at that level to do that. The camera's great. But yeah, so I've already written code where it draws a dot, a green dot on the middle. It's not really hard. And that's where, as I mentioned, you'd point the beams at. And then after you have those values, you would track them, you know, in memory, and as the robot moves, you apply like physics tracking using the IMU and what is it? Inertial displacement or something, that you can tell how far you moved based on the time and how long you accelerated for. But yeah, it will work. It's just it'll be crude because there's like so many sources of error and my methods are crude. Yeah.